All right, hello, this is your review for Unit 5. So this first one is going to be our integration by parts. We're going to have u equals x, du equals dx, dv is going to be the rest of it. Doing your antiderivative, it's going to be 1/3 because of that 3 that's there, sine 3x. So then we're going to, if you write it this way every single time, it's going to turn out the same way. We're going to multiply across this diagonal. So 1/3 x sine 3x minus integral of the bottom part. So 1/3 sine 3x dx. First part stays. We're going to need another 1/3. So a third times a third is going to be a ninth. And actually, it's going to be negative cosine. So the negatives are going to cancel. Well, cosine of 3x and then plus c. All right, this next one is going to be our partial fractions. So I'm going to take this whole thing. Oh, -3. And we're going to have it equal a over x minus 3 plus b over x plus 4. You multiply each of these fractions by this denominator. This whole part's going to cancel out. We're going to have a times x plus 4 plus b times x minus 3. All right, if x is -4, we're going to have -20 equals, this part will cancel, b times -7. So b will be positive 27ths. If we let x equal +3, we're going to have 5 times 3 is 15 equals a times 7. So a equals 15/7. We're going to put this part back into the integral. So it'll be 15/7 over that x minus 3 plus b is 27 over that x plus 4, and they are both going to become ln. So lots and lots of algebra, hardly any calculus. All right, next one is also going to be our integration by parts. We have a 3x times an f prime of x, and we're going to use our information in the table to evaluate it because there are actual boundaries. This part we're going to just hold on to for a second. This is the actual problem. So u is going to be 3x, du is 3dx, dv is all the rest of it. When you do your antiderivative, since this is f prime, when you go backwards, you just get f of x, which is good because that's in the table. So if we multiply across this way, we're going to get 3x f of x such that 0 to 2. So that part's done. We're ready to evaluate it. This part's still in the integral. It's going to be 3 f of x dx, and my boundaries are 0 to 2. So this first part, we're going to do upper minus lower. If I plug in 2, 3 times 2 is 6. F of 2 is 7. If I plug in 0, the whole thing is actually just going to be 0. And then this part, ignoring that 3 for a second, integral from 0 to 2 f of x dx is given right here. We're told that that's 3, and I just need to multiply it by that 3. So 3 times 3 gives you 9. We get 42 minus 9, which is going to be 33 for our final answer. So you get a numeric answer which represents area. All right, find the area between this graph and the x-axis for 2 to forever, okay? So it's going to be integral 2 to infinity of that function. So this is your improper integral. We're going to do limit as b goes to infinity, integral from 2 to b of that equation. You're sort of just rearranging symbols for that step. You don't really do anything. You just sort of, put b in there and move the infinity to a limit. All right, this is going to be a u substitution, but to cancel out the -4, we just need a -1/4. So just put that out front. We have such that 2 to b. We're going to write limit one more time. This is upper minus lower. So basically, you're just going to plug b in. What I'm going to do, though, since this is a negative exponent, is bring it down to the denominator so we can see what this looks like a little bit better. Again, the negative exponent brings it down here. I'm going to do the same thing with this one. It'll be -1 over 4e to the 8th. Again, negative brings it down to the denominator. 4 times 2 is 8. Then we're going to evaluate the limit. As b goes to infinity, this part gets infinitely huge. You have 1 over a gazillion, which goes to 0. These negatives are going to cancel, so it's positive 1 over 4e to the 8th, which is a number. E is 2.7-ish, so that is a value that represents area. All right, same thing for this one. We're going to do limit as b goes to infinity, integral 3 to b. I'm going to write it as x to the negative 2. Keep my limit. When you add 1 to the power, it becomes less negative, and then we would need a negative in front. So that is going to look like that, negative 1 over x, such that 3 to b. Then we're going to do upper minus lower. So negative 1 over b, and then this would be negative 1/3. Again, going to infinity. If b is infinitely large, this whole part goes to 0. These negatives cancel, so 1/3. Right, over here, we need to notice that we have a vertical asymptote at 0. You can't have a 0 denominator. So we're going to break this into negative 1 to 0, and then 0 to 2. We're going to start with just the first half. If we get an answer, we'll do the second half and then add them together. But if this first half diverges, then we don't even need to do the second half. So you kind of don't want to do more work than is necessary. We're going to just see what happens. So limit as b goes to 0, negative 1 to b. This is the same thing that we had over there, conveniently. Keep our limit in there. It's going to be negative 1 over x, such that negative 1 to b. Kind of just a lot of writing the symbols over and over again. When you get to advanced mathematics, it's more about notation than really anything else. Negative 1 over b, and then if we plug in negative 1, the negatives will cancel. We'll just get 1. Then when we evaluate the limit, if b goes to 0, you get a 0 denominator, and so this diverges. And so we don't even have to do the second half. We know that the whole thing is going to diverge. All right, for this next one, we're doing a derivative of an integral. They're going to cancel out, and essentially we're just going to take this 3x and plug it in for t. But there is a chain rule there. We have to multiply on the derivative of 3x, which is 3. So I usually just go ahead and put that out front. Now, if you take 3x and square it, you're going to get 9x squared. So again, an integral and a derivative are inverses. They undo each other. You kind of don't do too much there. The most math we did was we squared the 3x, but just remember there's a chain rule. All right, graph of f is shown. We're not going to be asked questions about f, though. We're going to be asked questions about g. G is an accumulation function. The accumulation begins at negative 1. First thing we want to do is take the derivative. Like we just did here, all you're essentially doing is taking this x and plugging it in. So we just want to link those together. G prime is f of x, and that's this graph. So this is the graph of g prime, which is our derivative. This is our sticky note stuff. Right, on what intervals is g, which again is not the graph you're looking at, decreasing, that would be where this graph is negative or below sea level. Concave down would be where this graph is decreasing. Just look at your sticky note. So we want where this is negative and decreasing, which is going to be for this portion right here. So from 2.5 to 4. This looks like an ordered pair, but it's an interval from 2.5 to 4. All right, relative maximum is a change from positive to negative. That's going to happen right here at 2.5. We have a change from above the x-axis to below. All right, an equation, you need a point and a slope. So we want our point to be 2 comma something, and then we'll get our slope. 2 function g, which again is not this graph. G is your accumulation function from negative 1 to wherever you're going. So to get this y value, we want to accumulate from negative 1 to 2. So negative 1 is here, 2 is here. A lot of different ways you can break this up. I'm going to do 2 trapezoids. So I'm going to do this trapezoid right here first, and then I'll do this one second. So they're both on their sides. 1/2, this is the height, which is 2. And then we're going to add the bases together, so 1 plus 3. And then my other trapezoid, this one right here, 1/2, the height is 1. And then my bases are 3 plus 1. So let's see what we get there. These are going to cancel. This first part's 4. 3 plus 1 is 4. Half of that is 2. So we get 6. Slope comes from the derivative. This is the graph of the derivative. So I just want that value at 2, and at 2, that value is 1. And then we're going to just put it all together. Y minus 6 equals 1, x minus 2. So again, this is your derivative graph. When you want your slope, you just find where that point is. To get your actual value, you need to do your accumulation. So remember, this is the derivative graph, but you're being asked questions about this accumulation function. All right, on what intervals is f of x decreasing? We're going to get our derivative, which again, you're basically just taking this x and plugging it in. A derivative of an integral, they're going to cancel out. So negative 2x squared plus 6x plus 8. Decreasing is where your derivative is negative. So we're going to need to do a whole bunch of algebra, make our number lines, put in our pluses and minuses, and find where this is negative. I'm going to factor out the negative 2 to start with. When you factor out a negative, everything's going to change its sign. And then we're going to split this up. It will be 1 and 4. We want plus 1 minus 4 to get a negative 3 in the middle. So our factors, we have a negative 2, we have an x plus 1, we have an x minus 4. I couldn't ignore that negative 2. If it was a positive 2, you could just throw it out. You would have pluses the whole way across. But when it's negative the whole way across, which is going to negate everything else that we do. So I did need to keep that in there. This one changes at negative 1. Put all my pluses in here. This one changes at 4. So I'm going to put in all my little balloon strings. Negative times negative times negative will be negative. These two negatives would cancel, and then times a positive is positive. This one's going to be negative. If nothing weird happened, it's going to alternate. Now we want our answer to be where this is negative. So that's this first section. So negative infinity to negative 1. And then also this section over here, so 4 to infinity. The way this question shows up on the test is you have a graph and you're looking for the derivative graph. So I just threw a couple examples on here of what it should look like. The derivative of a cubic is quadratic. The derivative of quadratic would be linear. The derivative of linear is constant. So you're going to have choices of graphs, A, B, C, D, and you're going to pick the one that looks correct. Okay? Particle's acceleration is given by 12t. At time 0, velocity is 7, position is 3. So those are your initial conditions. We want our position at time 4. Or we're going to have to work backwards. We were given acceleration. Let's go and find velocity. Antiderivative would be, well, we'd want it to be 1/2 t squared, but there's a 12 there. So it's going to be 6t squared plus our initial velocity at time 0 is 7. All right, working backwards again to get position, which again, S is for position, weirdly. This would be 1/3 t cubed, but there's already a 6 there. So it's going to be 2t cubed plus 7/2 t squared plus, and then our initial position is 3. So you're just working backwards. Instead of doing derivatives, you're doing antiderivatives, and they gave you these initial conditions. And then what we want to do is plug in 4. We ended up with a fraction in this one. On your test, there's not a fraction, so it'll be a little bit easier. 4 cubed is 64. Double that is 128. 4 squared is 16. 16 divided by 2 is 8. And then 8 times 7 is 56. Oops, that should be a plus. And then plus 3. So 56 plus 3 is 59. 128 plus 59. Let me just do that real quick. That would be what, 17? Did I do that right in my head? 8. There we go. 187. Again, there's not a fraction on the one, how it turns out on your test, so it'll be a little bit easier. Also, it'll be multiple choice, so you'll have choices to choose from. Usually, if you get close enough to the answer and you start looking at your choices, you'll be able to figure it out. All right, a word problem. The rate at which students finish their calculus test in students per minute, so something per something else, it is a rate, is given by C of t, which is this graph. So this is a derivative graph. It's a rate. How many students finish, so not a rate, just how many people finish from 0 to 30. So we want to accumulate students from 0 to 30. Again, a bunch of ways you can break this up. I'm going to do this trapezoid and then this triangle. So trapezoid, 1/2, the height is here. It's not 2, be careful. This is 10. And then we're going to add the bases together. So 10 plus 25. And then a triangle is 1/2 base times height. So that's 20. And then the height is 25. You're going to have to sort through that because it's a multiple choice question. So 1/2 of 10 is 5. 10 plus 25 is 35. Half of 20 is 10 times 25. So that part's going to be 250. What is this going to be? 35 times 5. I'm just going to work that off to the side. 175. And sometimes you have to do that. If it's multiple choice and you have to keep going and you don't get a calculator, it's an important skill to be able to, add, subtract, multiply, and divide off to the side as a margin problem. And again, I get people that get embarrassed that they wrote something off to the side. That's literally your brain working. Those are literally your thoughts. I do it all the time, right? So 250 and 175. I should be able to do that in my head, but my brain is not working here. What is this? 12. So 425 students. That's a large class. All right. So for this question on your test, it's supposed to be non-calculator. I'm going to let you use your calculator for part B because I feel like it got, in my opinion, needlessly difficult with the calculations. So it's supposed to be a non-calculator question, but I'm going to let you use it for part B. But this one is still going to be, this is going to be our last non-calculator one. All right, a swimming pool is leaking at a rate of this many gallons per minute. So this is our rate out. There were 20 gallons to start with, so that's our initial condition. And water gets pumped in at a rate of 5 gallons per minute. So this is the rate in, and this is the rate out. And this is what we started with. How many gallons leak out from 0 to 10? Out. That's the only thing we need is this. We want to accumulate leaked out gallons from 0 to 10. I'm going to write that as t plus 6 to the 1/2 dt. So antiderivative, we're going to raise that by 1. So it'll be 3/2. Out front is 2/3, such that 0 to 10. And we're just going to do upper minus lower. And because this one is free response, you do not have to evaluate it. So it'll be 2/3. I am going to do 10 plus 6 and get 16 to the 3/2. And then if you plug in 0, 0 plus 6 will be 6 to the 3/2. It didn't ask for units, but if you're interested, it's gallons. It's just the amount of gallons that leaked out, whatever this comes out to from 0 to 10. It's how much water we lost. All right, when from 0 to 30 is the amount of water in the pool a maximum? This is an absolute maximum. It is a candidate's test. The justification is going to be the table. So you won't have to write out a sentence. All right, we're going to make our table, and that will be our justification. So we need an equation for water. I'm just going to write water equals. You can make up a letter. You can write f of x. Doesn't really matter. But be careful with f of x because, you have w of t and r of t. The letters of the alphabet gets difficult to juggle sometimes. I'm just going to write the word water. All right, we started with 20 gallons. And we are going to add in 5 gallons per minute. So that's 5x. And we're going to leak out an accumulation of gallons from 0 to whenever of this. So that is our equation for our water. It's what you start with plus what you gain. That was a constant rate minus what leaked out. That was not a constant rate. I had to do an accumulation there of the amount leaked out. It's similar to what, not similar, it's the exact same thing as what we did here, except instead of an actual value like 10, we are till whenever. All right, I'm going to get my derivative. So I'm just going to call this water prime. That's kind of personal preference, how you want to write this. That's just what I'm going to go with. Just how many gallons we've got in there. I guess you could write gallons instead. 20 is a constant, that's gone. Derivative of 5x is just going to be 5. Derivative of an integral is going to cancel. You're just going to take this x and plug it in. So square root of x plus 6. I'm going to set this equal to 0 because that's how you get critical points, is derivative equals 0. So then to solve this, we're going to add this over. We're going to square, and we're going to subtract the 6. Now I'm going to make my table. I have times, and I have amount of water. So we want to go from 0 to 30. And then our critical point we found is 19. At time 0, we had 20 gallons. That was the initial condition. These ones I'm going to let you use your calculator. You have to plug these into your water equation. Now, hold on a second because I am going to have to share my screen. I have to exit full screen here, and I'm going to have to share and then bring up my calculator. So just hold on a second. All right, so here's our calculator. We started with 20. And then we accumulated 5 gallons per minute. So we're doing at 19 minutes. So 5 times 19 minus, we want to integrate from 0 to 19 of square root of t plus 6 oh, you know what? It's going to want me to put a parenthesis there, I think. dt. So I'm going to write that on my paper. Or actually, you can see the paper. There's a little box at the bottom of the screen. So 41.464 gallons. And then we're going to do the same thing, but change the 19s to 30. And so that is 35.797 gallons. So let me stop sharing. We'll go back to the paper and write out our final answer. And our maximum amount, max is 41.464 gallons at time equals 19 minutes. You want to get in the habit of writing it this way every time. In this case, they asked for when, so they wanted the 19 minutes. Sometimes they ask for the amount though, and sometimes they ask for both. So if you write it this way every time, then you're always going to get it right. Just say, this is the maximum amount at this time. And again, the chart is the justification, so you don't have to do anything else. So what happened was we had this maximum at 19, and then the water started leaking out faster than it was coming in. So we lost water over time, net amount of water. Right, temperature of water is given by a function C of T. Now, that's not a rate, that's just the temperature. We've got minutes and we've got degrees Fahrenheit. So what does this mean? So you're accumulating temperature from 0 to 12 of the rate, so C prime. So it's just how much your temperature changed from 0 to 12 minutes. So it's the change in temperature in degrees Fahrenheit from 0 to 12 minutes. So it's the temperature you started with, and then the temperature you ended with. It's how much you changed in between. So it's just the change. What is an interpretation of this? Now, this is almost the same thing. You have this change, but it's where you started. So if you take where you started plus however much you changed, that gives you your temperature at that time that you ended up with. So this is just going to be the temperature in degrees Fahrenheit at time 12 minutes. So again, if I take the temperature it started out at, whatever degrees, and I add the amount of degrees that it changed, then that's going to give me where I end up at the end of those 12 minutes. All right, I like these ones because we're just going to set them up and stick them in the calculator. All right, a swimming pool is filled at a rate of, they're not going to give you nice functions though, so you got to be careful typing things in. But it is a rate, it is gallons per minute. There were 60 gallons to start with. How much water is in the pool after 30 minutes? All right, we're going to take our 60 gallons and accumulate water going in for 30 minutes. I'm going to share my screen, or actually, you know what? Let me set this one up too, and then I'll share my screen and I'll type them both in at the same time so I don't have to keep switching screens. All right, there's initially 30 people at a party. They're leaving at this rate of people per hour. How many people are there after 2 hours? So we're going to take the 30 we started with. We're going to just subtract how many leave over those 2 hours, R of T dt. Let me share my screen. And we'll just type these in. All right, so the first one, 60 plus integral from 0 to 30. Oops. There we go. All right, and that is 20 parenthesis 5 minus e to the power negative 0.12 t, close all these parentheses, dt. And then make sure it makes sense. We are filling up the pool, so we should get a bigger number. So 2,897.887 gallons. It'll be multiple choice though, so you don't really need to worry about the units. All right, for this one, let me just start all over. I'm going to do 30 minus integral 0 to 2, and it is 3e to the power negative 0.02 t squared, close parenthesis, dt. All right, and make sure it makes sense. We started with 30 people and they're leaving, so we should end up with less people. And I'm going to round this to a whole number so that we don't decimal point a person. I can't remember everything in the world. I feel like I remember this one on the test was worded differently, and you still needed to do a plus there, even though they were leaving. The way that they worded the equation, it took care of, like if you put a negative, it ended up being like a double negative. Just make sure it makes sense. if you put, like, for example, let me show you. If I put a plus here, I get a number bigger than 30. People are leaving. If you started with 30 and they're leaving, you can't end up with 35. So like if you try it one way and it doesn't make sense, just try it the other way. Also, if you do it wrong, likely your answer that you get will not show up as one of the choices. So you'll be like, oh, whoops, and then fix it. All right, last one, our free response here. We have particle P and particle Q. They're both moving. We're given the velocities for both of them. So velocity of P is given by this. And then velocity of Q is given by this. Again, be careful typing them. They're not going to give you nice functions. They're going to be messy. And then you're given initial conditions for both of them. Position of particle P at time 0 is 3. Position of particle Q at time 0 is 7. So find positions of both of the particles at time 2. So I'm going to just label these. P starts at 3, and we want to accumulate from 0 to 2 of this. Just write velocity of particle P. When you go and type it in the calculator, you're going to put that, but just, for the sake of time, don't write the whole thing out. Also, if you copy it wrong, then it's wrong. All right, for Q, it starts at 7. We want to accumulate from 0 to 2 the velocity for Q. And now I'm going to go to the calculator and just have fun typing those in. Button pushing is a skill that you need, though. So this is an important thing to, practice. Okay, what was velocity for cosine? Okay, so when you type in sine or cosine or any trig function, you need to be in radians. Radians is the default. So unless you changed it, it should still be radians. Like if I come over here and this is in the way. See how it's already on radians? So you can check it if you want, but if you haven't messed with it, radians is the default. So it should already be in radians. I started yapping, so let me just double check that I typed that all correctly. Cosine t, okay, so 3.538. I'm going to leave that in there in case I need it, because this is an A, B, C, D problem, and you never know if you might need that again. So I'm going to leave that there. All right, and then velocity for Q. Parenthesis, t minus 1.3, close parenthesis, times 1.89 to the power t, close this parenthesis, dt. All right, so I got 6.622. And that is all that one asked for, so we're done with part A. Are the particles moving towards or away from each other at time to justify your answer? So we are going to need to write a little sentence here. I found where they are, I just need to know what direction they're moving. So that's going to come from the velocity. So I'm going to do velocity of particle P at time 2, and I'm going to do velocity of particle Q at time 2. And actually, I don't need to say what they actually equal. I just need to know what direction we're going. So I just need to know if they're positive or negative. So you're better off just saying positive or is negative, because if you type it wrong, but it comes out to the correct sign, you can sort of just get away with getting it correct. If you put the actual wrong number down, then it's going to be wrong. All right, so I want this to be 2 to the power 1.7. All right, so that's velocity for P. And then Q, I'm going to have 2 minus 1.3 times 1.89 to the power 2. All right, so I'm not going to write these actual numbers. I'm just going to write that P had a negative velocity and Q has a positive velocity. All right, and you can say is negative, or you could say less than 0, and you could say is positive, or you could say greater than 0. Now, they are not going to grade any kind of like picture that you draw, but I do like to draw a picture so I can see what's going on. Just helps me mentally. P is at about 3.5, and Q is at about 6.6. So I'm going to just draw this so I can see it. So P is about right here, and Q is about right here, roughly. Particle P is moving to the left. This velocity is negative. And particle Q is moving to the right. That velocity is positive. So that I can see visually, are they moving towards each other or away from each other? And I can see that it's away. So away from each other at time 2, specifically, because at a different time it might be different. because, all right, now here's how you need to say this. You need to say position of Q is greater than position of 3. You need to say this one's over here and that one's over there. Position is S. So for Q at time 2, that position is greater than position for P at time 2. I wrote this out with symbols. I used S for position. The other thing you could do is write it out in words. Position of particle Q is greater than position of particle P at time 2. Like if you were more a words person than a symbols person, totally fine, right? But you need to, in some capacity, say this one's over here and that one's over there, okay? And P is moving left and Q is moving right. You already said that this velocity is negative and this velocity is positive. So over here, you can just say moving left and moving right. So you're saying this one's here, moving to the right, this one's here, moving to the left, therefore they're moving away from each other. There's a ton of different ways you can word that. I think this is the most succinct way to put it. All right, find the acceleration of particle P at time 2. We have velocity, we need to get to acceleration, so we're gonna do a derivative. So we're gonna do, for particle P, we're gonna do the derivative at time 2, and I'm going to type that in the calculator. I think I'm gonna type this just V of t. I'm not gonna put a subscript of P on there. Oops, I need an equal sign though. All right, so velocity equals cosine of t to the power 1.7. And I want to do the derivative at 2. So I got 0.296. All right, so cool. That's going to be worth a point. We found that. Is particle P speeding up, slowing down, or neither at time? Oh, that should say 2. Sorry. 2. They're all going to be 2 because we're all talking about the same time. This is going to be 2. This is going to be 2. This is going to be 2. That should have said 2. That's just a typo. I am so sorry. It's going to be the same on your test. I don't remember if it's 2, but they pick a time and the whole problem is about, the same time. So is particle P speeding up, slowing down, or neither at time 2? We found that our acceleration, which is our derivative of velocity, is positive. And back here, we found that our velocity is negative. And you can go back to the calculator and look at that. But velocity was negative, acceleration is positive. So we're going to say slowing down at time 2 because velocity for P at 2 and acceleration for P at 2 are opposite signs. If they were the same sign, would be speeding up, or you could say speed is increasing. All right, find total distance traveled for particle Q from 0 to 7. So total distance means that you need an absolute value of your velocity. So I'm going to do the setup. I believe it's 1 point for the setup and then 1 point for typing it in the calculator. So let me share my screen. Go back to the calculator one more time. And I think here I can go back. See, I left everything in here because you're never sure where you're going to need something again. This one was Q. I don't need the initial condition for this. And also I want to change this. We want it to be 0 to 7. And I'm going to just highlight all of that and come down here and put an absolute value around it there. So I didn't have to type the whole thing all over again. So it came out to 565.555. It's fine for it to be a big number. When you do total distance, oftentimes it is. And also, I made up this problem, and sometimes the numbers get weird when Ms. Cole is the one that makes up the problem.